Welcome to a section of this course. Today we are going to speak about integration by substitutions of some trigonometric functions as well as algebraic functions. Okay, so we'll use some standard substitutions. Let's try to solve. We have 1, 2, 3, 4, 5, 6 questions. So let's try to solve. 1. Integral of sine of x upon sine of x minus a dx. Okay. Now here, this in this denominator we have sine of x minus a. Okay. Now if I expand this with the help of sine a plus b, it's become complicated. Okay. So what to do is we have to minimize this angle by substituting. If I put t equals to x minus a, then dt will be what? Dx. Okay, dt will be dx. So therefore this integral will be integral of sine x. What is x? Therefore x equals to what? X equals to t plus a. Okay, from here x equals to t plus a. Okay, and dt become a dx. Okay, this dx become dt, and sine of x will be what? T plus a. Okay, this x will be sine of what is x? T plus a upon sine of t, and dx become a dt. Okay, now all variables I am changing from x to t. Why? Because if I expand over here this formula of sine a plus b, then I will become a linear one, and then I can distribute sine t to each and every functions. Okay, now we know that sine of a plus b by trigonometric formula is same as sine a cos b plus cos a sin b. Okay, we can use this formula over here. This is same as sine of integral. Still we have not done any integrations. Okay, sine of what? Apply this formula. What is this? Sine of t cos of a plus cos of t sine of a upon sine of t dt. Okay, now this sine t I can distribute in this term also, this term also. Now if I distribute in this term, sine t and sine t will get cancelled, then it will be what? Only cos a. Okay, is equals to sine t gets cancelled, cos a integral cos of a plus. Okay, now here will be sine of, I can write sine a is constant over here, sine a into cos t upon sine t integral dt. Okay, now since integration is with respect to t, therefore cos a is constant. Okay, so I can send this integral outside, integral of cos a dt plus here sine a also constant because integration is with respect to t, cos t upon sine t dt. Okay, now here integral of dt is a dt is only t, cos a into t plus sine of a. Now if I differentiate sine t, if I am getting cos t, then that is log of integration from this is same as log of sine of t plus some constant of integration c. Okay, now here the variable which I already put t equals to x minus a, so we have to substitute over here, is same as cos of t is what? X minus a. Okay, cos a into x minus a plus sine a into log of sine, what is t? T is x minus a, okay? X minus a plus c, okay? This is the required answer. Otherwise, what we can do is, you can use some tricks over here, okay? Now, instead of sine x, what I can say is, x is same as x minus a plus a. Why minus a plus a? Because this sine x, since x minus a is there, here I will be getting x minus a in numerator as well as denominator. Okay, let's try in that way also. So I will be using this formula. Instead of sine x, what we can do is, this is same as sine of, instead of x minus a plus a. Why? Because minus a and plus a gets cancelled, and sine x is same as sine this, okay, upon sine of x minus a dx. Why? Because since denominator we have x minus a, so in order to get x minus a, same angle, so I can say instead of x, I can say x minus a plus a, okay? Now let's consider this is a and this is b, it is of the form sine a plus b. Let's expand this integral of sine of a plus b is same as, this is, consider this a and this b, okay? Sine of x minus a into cos of a plus cos of x minus a into sine of a upon sine of x minus a dx, okay? Just here applying this formula, okay? Here consider x minus a as a and plus b as a b, okay? Now I can distribute similarly this term over here and this term over here. Now if I distribute this term over here, sine x minus a will get cancelled and I will be getting cos a, okay? Integral of cos a with respect to dx will become a cos a into x, okay? So this is same as, this upon this is sine x minus a gets cancelled. I am getting cos of a into dx plus integral. Similarly, what we have is sine a is constant over here, sine of a, and integration of cos a, let's write one step, cos of x minus a upon sine of x minus a into dx, okay? Now what we have is cos a into dx is what? This is cos of a into x plus sine of a into, that is log of sine of x minus a plus c, okay? This is required answer, okay? This way also we can solve, okay? Similarly, if we have cos of x upon, instead of sines, if we have cos of x upon cos of x minus a, or if we have cos of x minus a or plus a upon cos x, similarly in this way we can solve, okay? Now let's solve this second equation. In the second equation, what we have is, we have sec square upon 3 plus 10x. So what you have to think is, if I put something, then that differentiation should get some values in the integrations, okay? So in that way you have to think. Now in this integral, if I put 10x equals to u, okay, and then differentiation of 10x is what? Sec square x dx. So I am getting du, if I put u equals to 10x, and I will be getting du as this term. So it has meaning. Similar, let's solve this one. So, integral of sec square x dx upon 3 plus 10x. Okay, let's put u equals, why I am putting u equals to 10x, because if I put u equals to 10x, I will be getting sec square x dx. Okay, so if I put u equals to 10x, then du will be differentiation of 10x is what? Sec square x dx. Okay, this same as this become a du upon 3 plus u. Okay, now we have, if you differentiate this term, if you are getting, so let's see, you just check d by du, since parameter is u over here, d by du of 3 plus u is what? Differentiation of constant is 0 and d by du u is 1. Okay, or you can say this is 1 into dx. Okay, here this is numerator and this is denominator. If you differentiate denominator, if you are getting numerator, that is log of, that integration is log of denominator. Okay, that is integral of 1 by x, for example, say dx is log of x. If you are differentiating x, if you are getting this term, then that is log of x. Okay, therefore this is same as log of 3 plus u plus c. What is u? U is what? 10x. Log of 3 plus 10x plus c. Okay, this is the required answer. Now question number 4, question number 3. In this also, if we have to substitute what? 3x square plus 3 as a u. Okay, and we will be getting something, the u will be something in this form. Okay, let's try to solve this one also. This one, 3. Integral of twice x upon 3x square plus 3 raised to 5 dx. Now in this term, if I put u equals to, 3x square plus 3, then differentiation, I'll be getting something over here. Okay, let's try. If I put u equals to 3x square plus 3, then du upon dx, or you can say du equals to 3 to the 6x into dx. Okay, now I'm getting 6x into dx. Now these two set I can send outside because it's a constant, so I'm getting x into dx. So in x dx I'm getting x dx is same as what? Du upon 6 is same as x into dx. Okay, now these two I can send outside. If I send outside, then x dx will be what? Du upon 6. This same as 2 I'm taking outside, since it is constant. X dx become du upon 6. This is what? U. Okay, u raised to 5. Okay, now this whole become u and u raised to 5. This same as 2 3. This if I can cancel, it's 1 by 3 integral u raised to what? Minus 5 du. Okay, this is by applying formula of integral x raised to n dx is what? X raised to n plus 1 upon n plus 1. Okay, now here I am getting u raised to minus 5 plus 1 upon minus 5 plus 1 plus c. This same as 1 by 3 u raised to minus 4 upon minus 4. What is u? You have to come back. Okay, u is what? 3x square plus 3. This same as 3 4s are 12 minus 1 by 12 What is u? U is 3x square plus 3 raised to minus 4 plus c. Okay, this is the required answer.